Hello, I'm Angelica Ponzio, professor at the Architecture School and the Research and Graduate Program in Architecture at Federal University of Rio Grande do Sul. I am here also as the coordinator of our BIM cell group. Alongside me is Victor Schultz, doctoral candidate researching BIM integration in architectural education. Our team focuses on studying ways to implement BIM in architectural curricula through innovative strategies, informed by both research and collaboration with national and international BIM networks. BIM adoption in Brazil has been driven by a top-down government approach since 2018. Key milestones include the launch of the BIM-BR strategy and regulations mandating BIM use for federal public projects. Academically, the National Conference on BIM Education began in 2018, and in 2021, the National Association of Construction Technology, ANTAC, formed the BIM Cell Network, promoting local BIM cells and curriculum plans. In 2022, we launched the BIM Cell at our architecture school to enhance BIM integration. The same year, the BIM Academic Portal was established, providing resources for educators. By 2024, the Ministry of Development issued a comprehensive guide for BIM curricular implementation. Despite these advances, embedding BIM in undergraduate programs remains challenging. Today, we'll share how our initiatives address these challenges. Our journey began with studies conducted within a registered research group focused on exploring creative procedures in design education. BIM-related activities commenced in 2016, with extension courses laying the groundwork for introducing BIM concepts. In subsequent years, BIM was incorporated into core courses such as graphic representation, and research was conducted at the postgraduate level. This included a master's thesis by Schultz on using BIM as a learning platform for teaching woodframe construction in Dr. Ponzio's fourth semester design studio. Joining the ANTAC BIM Cell network in 2021 further advanced our integration, aligning us with national initiatives and providing a common platform for discussion and research references. It's important to note that in Brazil, the undergraduate Bachelor of Architecture program lasts 5 years and is divided into 10 semesters, with students becoming registered architects upon graduation. Master's degrees are typically 2 years and culminate in a written dissertation, while doctoral degrees last 4 to 5 years and require a thesis for completion. Our BIM cell is made up of a diverse group of professors, doctoral and master's students, and undergraduates from the architecture and urbanism departments and postgraduate programs in architecture, design and urbanism. Our shared mission is to promote BIM awareness and integrate its practices into architectural education. The collaboration within our team fosters a rich exchange of knowledge, driving both research advancements and the practical implementation of BIM strategies. Recently, we presented the inauguration class to the architecture school, highlighting the BIM cell activities and power course and showcasing successful local and international BIM practices. The BIM cell's objectives include raising awareness, implementing, and disseminating BIM throughout the undergraduate curriculum while offering robust support to students and professors. Our aim is to foster meaningful collaboration, supported by postgraduate research and outreach initiatives, including extension programs accessible to the wider public and guest lecturers. When we joined the ANTAC network of BIM cells, we applied specific protocols to evaluate our course's BIM maturity and the potential for integrating BIM into the curriculum. The first protocol used was the BIM maturity metric, which assessed our course based on processes, technologies, and policies. The results showed a medium maturity level. This ranking was attributed to the presence of computer labs, BIM integrated courses, and the application of BIM in a design studio. The assessment also highlighted areas that need further development, guiding our ongoing efforts to enhance BIM education comprehensively. The BIM maturity metric evaluates our course's BIM integration across 3 dimensions: policies and guidelines, processes, and technologies. Policies and guidelines cover all initiatives, actions, and institutional visions related to BIM. Processes assess the performance of teaching, research, and extension in BIM. Technologies focus on the technological or physical infrastructure needed for BIM teaching development. Our total score of 48, 13% places us at a defined maturity level, indicating strengths like active BIM courses and impactful research, but also highlighting the areas where we need to expand. Our second evaluation used the curriculum interface metric to identify where BIM can be naturally embedded into our courses. Each course was analyzed and categorized based on its potential BIM interface, using categories like technical, concept, and modeling, collaboration, integration, course integration, design and construction phases, architecture and engineering disciplines, theory or practice. This metric has the objective to pinpoint which courses are best suited for BIM integration, guiding strategic curriculum development to maximize BIM adoption and collaboration opportunities. The curriculum interface metric helps visualize how BIM can be integrated across our curriculum. Instead of following the original method of analyzing the curriculum by organizing courses into core areas like basic, professional, and activity modules, we created our own approach. We used distinct colors to group disciplines of the same nature to understand how BIM competencies could be applied. Each color represents a course category. Orange for architectural history, yellow for graphic representation, green for design studios, blue for building systems, purple for construction scheduling and cost estimates, and red for urbanism. Our 5-year program, divided into 10 semesters, builds from foundational to specialized courses. We found that 35 out of 61 courses could incorporate BIM, providing a strategic foundation to enhance BIM integration effectively. Despite the identified potential, implementing BIM in undergraduate courses faces several challenges. First, curricula often lack space for dedicated BIM courses, and bureaucratic processes require significant time and financial resources to propose curriculum updates. Additionally, existing courses often have insufficient workloads to cover BIM content comprehensively, and there is a pressing need for faculty training. Furthermore, most BIM adoption experiences are confined to isolated courses, leading to non-continuous BIM training and often reducing BIM education to mere software use rather than a holistic approach. Given these challenges, the BIM cell has initiated its actions by planning gradual BIM implementation activities. These include delivering open lectures to academic communities, organizing training workshops for both professors and students, and developing teaching materials such as BIM models, templates, and handbooks or guides. These propositions aim to lay the foundation for future integration into curricular courses, facilitating a smoother and more continuous adoption of BIM practices. We have been implementing these resources in a few disciplines, either directly linked to postgraduate dissertations and/or as requested by professors, establishing a practical base for further BIM adoption. These include BIM models, which simulate course content to help students visualize and understand complex concepts, and templates, which are preset digital files that enhance academic project representation in design studios. Accompanying these are handbooks and guides, providing additional didactic materials to reinforce BIM knowledge from conceptual to practical applications. Additionally, lectures and training workshops are useful to gradually introduce BIM concepts and softwares in the academic environment. To implement a well-structured proposition, the BIM cell has recently created an extension project to plan future activities. This initiative aligns with Schultz's doctoral research, which outlines a BIM training program consisting of 10 fast-paced BIM courses. These courses cover key stages of a BIM workflow, from architectural modeling and environmental analysis to model validation and 2D documentation. with a gradual increase in complexity, based on our previous experiences. These courses will be rolled out starting in 2025 in two ways. As part of the curricular courses that dialogue with the BIM courses themes that are directly linked to postgraduate dissertations and/or as requested by professors. Secondly, as independent extension courses. This dual approach ensures flexibility and widespread adoption, enhancing both regular and supplementary education. This diagram illustrates the possible scenarios on how the proposed BIM courses can be integrated into our existing curriculum. Each BIM course, such as architectural modeling and environmental analysis, aligns with specific years and curricular courses, gradually increasing in complexity. For example, BIM courses like plumbing systems modeling and electrical systems modeling are mapped to the second year, while advanced courses, such as model validation and spatial coordination, are placed in the third year. Cost estimates and construction scheduling are scheduled for the fourth year, with 2D documentation starting early to support foundational learning. By strategically aligning BIM courses with related disciplines, we aim to create a cohesive educational experience that enhances students' understanding of BIM throughout their academic journey. Our BIM training program is designed to stimulate the development of various BIM competencies, including modeling, environmental analysis, spatial coordination, scheduling, cost estimation, and 2D documentation. It also incorporates the teaching of different building systems, such as architecture, structural elements, and mechanical, electrical, and plumbing systems. Additionally, the program addresses multiple stages of a building's life cycle, from feasibility studies and design to construction scheduling, on-site construction, maintenance, and even requalification or demolition, providing students with a comprehensive understanding of BIM in practice. Our approach focuses on promoting a continued BIM training program and investigating a flexible implementation strategy that integrates with the undergraduate curriculum. By fostering interactions between BIM courses and existing curricular subjects, students can connect BIM concepts with their coursework, ensuring that BIM education is comprehensive and not limited to software training. Additionally, this strategy supports professor training in BIM by involving them in the creation and delivery of BIM courses. The proposed BIM training program, including a curricular implementation guide under development by Schultz, will be valued by a group of BIM experts. When approved, it will be recognized as a design proposition within the design science research methodology, as defined by March and Smith, allowing for the solution to be generalized and applied to other architecture or engineering programs looking to implement or enhance BIM. Competencies. In the name of all CEL BIM members, we would like to thank you for your attention.